moving on.
Yeah. So next one, Amna Rana. Can you hear us? Okay. So maybe next one. Fatrili. I'm not sure if I pronounce the name right, but
It's hard. I can understand.
yeah. Okay.
So let's move on.
The next one, Taha Mahmood. Oh.
Hi, are you able to hear me?
Yes,
Yeah,
we can hear you.
Yeah, so basically I am doing my master's in environmental engineering from Otto von Guericke University, Magdeburg, Germany. And there was a course, wastewater management system, which triggered me to learn more about wastewater. So that's why I am here to share my experience and learn from you guys as well.
Yeah,
welcome, Mahmoud. Hi.
Welcome.
Thank you.
So next is Huma. Can you hear us? Hello, Huma.
Okay, next one. Ivana, can you hear us?
Hi, Ivana. Can
Hi,
you
yeah,
hear
I
us?
hear you. Just a second. Okay.
Hello.
Hi.
Hello.
My name is Ivana. I work for Grundfos and I'm responsible for water technologies in Grundfos for DACH area. And I'm here just like to see your experiences, to share mine, and to see how we can, yeah, cooperate maybe or something. So I wish to all of us very nice webinar. Thank you.
Thank you.
Thank you, Ivana. Okay, so next.
Next one, Stacy, can you hear us?
I can hear you.
Hello.
Hi, everyone. My name is Stacy. I work for Xylem Water Solutions, and I'm majorly based in clean water solutions, but I have great interest in wastewater. So therefore, that's why I'm here, looking forward to learning from your experiences. I'm based in Kenya. We have a new regional office in Kenya.
Ah, hello, Stacy. Welcome to the group.
Thank you.
So the next one, Ruba. Ruba, can you hear us?
Yes, I can hear you. Hello, Assalamualaikum. I'm from Pakistan. Currently, I am doing my master's in industrial chemistry, and basically my thesis is about wastewater, where I'm doing a thesis on a membrane technology, where I need to reproduce or recycle the used caustic in dyeing and sizing. Since my job is towards the textile sector, so as we all know that we really need the wastewater to in the technology. So that is why that's my thesis, and that's my basically membrane technology that I'm working on. So I'm really looking forward to grasp some information from this talk so I can use that in my thesis and my knowledge as well. Thank you.
Thank you very much. Okay, so next one, Devani, can you hear us?
Hello.
Hello.
Am I audible?
Sorry, can you say again? We can't hear you very clear.
Am I audible?
Your voice is not so clear as well. Maybe it's because of the bad internet connection, or
Yeah, I'll text in the chat box then about my introduction.
okay, thank you.
Okay.
Yeah.
Yeah, so next one, Saqib, can you hear us?
Hello.
Hello.
Hi. My name is Shakib, and I'm an MSc student at BUET, Bangladesh. And I'm here to gather some knowledge from a professional. Thank you.
Yeah, thank you very very much and welcome. And then we have Shubham Tripathi.
Tripathi.
Tripathi. Greetings, everyone. I'm here to gain some knowledge. I've been working on waste management field, and I've been seeing a lot of lack in leachate management and all. So I'm here to learn some things about water management.
Okay, thank you very much. And welcome to Wastewater Talk. And we still have Alex. Would you like to introduce a little about yourself, Alex? Okay, so maybe later. And
We had someone called Murad Sako.
yeah.
Hi, Murad Sako, can you hear us?
Yes, my name is Murad Sako.
Hello.
Yes, how do you do? I'm from Jordan. I work in an environmental testing laboratory. To be honest, I'm not an expert on the subject, but I am interested. So thank you.
Yeah, you don't need to be an expert for this wastewater talk. You can be interested in wastewater
I am
treatment.
interested,
I mean,
yes.
thank you. Thanks for joining.
Okay,
Welcome to
thank you.
wastewater.
Thank you.
So we still have, let's see.
Emin,
Yeah.
Austin. Yeah. Sorry if I
hello,
pronounce
that's
it wrong.
me.
I'm sorry if I pronounce it wrong.
Yeah, I can open my camera. Maybe you can see me.
Hello.
Yeah, hello.
Hello, I'm from Germany. I'm from the company PWT, and we are a turnkey supplier for wastewater treatment plants and water treatment plants. We perform all kinds of solutions for water treatment. And that's the reason why it can be interesting for us to go in contact with you and networking.
Sure, I mean, that's a great opportunity. Thanks again for the offer.
Yeah.
And welcome to the wastewater.
Thanks.
So we have one more. I think it's, I'm sorry if I pronounce this wrong. Ran T Tu Huang. I'm so sorry. I'm very bad at names. Hi, can you hear us?
Hello.
Hello.
Hi. Can you introduce yourself?
So I'm Hương from TNT Group. I'm work in environment department, Vietnam.
Okay. Welcome to Wastewater Talk.
Yeah.
Welcome.
Thank you.
Okay, I think we still have one left, and I'm not sure how to pronounce that. Oh gosh. I'm sorry. NGUY.
Yeah, she wrote in the chat box. So I mean, she introduced herself in the chat box. I guess she.
That's nice. Yeah.
Yes.
Thank you. And I'm sorry for the pronunciation. Yeah, and welcome. So yeah, I think so far for the round introduction, we kind of know each other, and I will share my screen and start the topic today. Yeah, so can everyone see my screen? Yes. Great. So today's topic, today we have the 6th episode of our wastewater talk, and topic is about exhaust air treatment. So first, as usual, a short introduction to wastewater talk to our new participants, that this program aims to promote the knowledge exchange and networking in the wastewater field around the world. So every month we have one live episode, and for each episode we bring a new topic for discussion. From this month on, we will provide 2 alternative meeting times, since we know our participants are located in different countries, different time zones. So we have one in the morning at 10 o'clock, which is this time, and also one in the afternoon at 15 o'clock, and this will be taken by Raghu. So our goal is that we want to share our passion in the wastewater treatment and wastewater management with you, and most importantly, to get to know you guys. And if you are interested in learning more about Wastewater Talk and rewatch the previous episodes, you can check out here. We will also make this presentation available afterwards. So yeah, you can check this on our Wastewater Talk website. So here's a list of the episodes that we have planned and covered so far for this year. Next month, we will talk about the sulfide balance in drainage systems. And in June, we will have a special episode where we have the live talk at IFAD in Munich this year. So whether you will be there at the IFAD or not, you are welcome to join this meeting and have a look of what's new this year at IFAD. Yeah. And as well, a quick introduction about Uni Techniques. So we are an engineering company based in Germany and specializing in the odors, corrosions, extraneous water, all kind of problems that we have in the sewer systems. So far, we have over 30 years experiences in this field. We offer engineering consulting, investigation of indirect discharger, and also inspect the sewer systems with drones and camera boats. We have a software called Sulfidus to simulate the hydrogen sulfide generation and emission in the sewer system. Also, we have the products against the odor, corrosion, extraneous water, and for the special cases, we also design the dosing and exhaust air treatment systems. Last but not the least, we have the products against the rats in the sewers. Yeah, so today's topic, the exhaust air. I would like to start this topic with the definition, with what is exhaust air. So the exhaust air is the air that is deliberately removed from the building and rejected back into the environment. So the ventilation systems in these buildings, which are normally equipped with the exhaust fans, are working to draw this air out of the building from the locations where we might have the problem with the air quality, the moisture and pollutants and odors. So basically we can see these air exhausting systems everywhere in our daily life. The first one in the bathroom, everyone have, in the bathroom, we have this extractor fans to remove the moisture from our bathroom. And also in the kitchen, the fans are working to take out the smoke, the oil, and the odors from the cooking. We can also imagine in the industrial area, in the factories, there are this kind of giant ventilator fans to replace the carbonized or polluted air inside of the factory with the fresh air from the outside. So what about exhaust air in the wastewater field? So when we talk about exhaust air in the wastewater collection and treatment area, we talk about the odorant emissions like hydrogen sulfide, like ammonia and volatile organic compounds, as well as the greenhouse gas emissions like the laughing gas and the methane and so on. And these all kind of emissions could come out from the wastewater treatment plants, from the pumping stations, or from the wastewater collection systems. So basically anywhere from the wastewater collection and treatment system. And can we do nothing about them, just let them there? Well, we can have a look of the one of the most common exhaust air problem in the wastewater field, the hydrogen sulfide. So here are some limit values for it. When it's over 0.1 ppm, we can already smell it, and it's very unpleasant, like the rotten eggs. And when it's reaching 5 ppm, it's already a threat to our health and even life. So it's a concern about the working safety. And there could also be the biogenic corrosion in our sewer in our sewer systems, as well as the treatment facilities when the hydrogen sulfide reach an average value of 0.5 ppm. So for a pleasant working environment and for our working safety and the protection of the sewer system and treatment facility, we really need to do something against this exhaust air from the wastewater system. So what we are doing, or what the technologies that we are using so far in Germany, is that we combine the oxidation from the ozone and the adsorption from the activated carbon together. And these two technologies have been applied in a wide range in the wastewater treatment field. So ozone is one of the most powerful oxidizers and has a lot of applications in the industrial area. It has also been used for disinfection in the wastewater treatment. And activated carbon is one of the most common thing adsorbents. The larger the surface, the higher the adsorption capacity. And one special thing about the activated carbon is that for each pollutants and for each adsorbents, there is a specific adsorption affinity, which means the pollutants which has been adsorbed by the activated carbon with a lower adsorption affinity will be replaced by the pollutants with a higher affinity. And so we want to make use of this effect by using the impregnated activated carbon, which has been designed specifically for the adsorption of hydrogen sulfide. So this is a table generally shows how strong, how powerful the ozone is, that it can react with a bunch of the chemical compounds that can be a problem from the wastewater treatment or collection systems. The general idea of this technology is that the exhaust air from the pumping station or the treatment wastewater treatment plant is directed into the reactor and react with the ozone. During this process, the peak load of the exhaust air, for example, hydrogen sulfide, will be removed, but we still have some residue load. And this residue load will then be removed by during the adsorption of activated carbon in the adsorber reactor. So in the end, we got the purified air, which can be exhausted into the environment safely. So we have been applying these technologies widely in practice in different projects. And here's one in Wolgast in the north of Germany. So the problem here is that at the wastewater treatment plant, at the screening building, we have the odor or the exhaust air problem from the wastewater inflow and the pollutants that has been screened out from the screening. So here we constructed an oxidation plant at the screening building to improve the working and operational safety. So here you can see outside of this screening building, we have these two black tanks. One is the oxidation reactor, and the other one next to it is the adsorber reactor with the activated carbon filled up. And here you can see the chimney where the purified exhaust air let out. Yeah, and the whole process is being controlled by the control cabinet here, where we have one of the most important part, the ozone generator and the ozone sensor and all the other kind of electronic controlling devices. And inside of the screening building, here is, so here we can see it's where the pollutants that has been screened out from the screening stored, and we cover or we encapsulate it with the curtains so that the exhaust air, the odors will be centered and then be directed through this exhaust pipe into the reactors outside of this building. And the result is that with the ozone generator, with the half of power and the exhaust fan output of 350 cubic meter per hour, we reduce the hydrogen sulfide from the peak value of 195 ppm to an average of 15 ppm. So even though this 15 ppm is still not in a total safety range, but compared to the treatment before compared to the situation before the treatment, it has been greatly improved. Yeah, and here's another project that I really want to introduce it. It's the project we had at Port of Kiel. So Kiel is one of the biggest city in the North Germany, and it has large seaport. So here the problem is that every day come and go many of these giant cruise ships, and also and the wastewater that has been collected during the trip needs to be treated, needs to be first discharged and then treated. But the wastewater treatment plant of the Kiel is actually at the other side of the seaport. So this wastewater from the cruise ships needs to first be discharged into the sewer system of the city and then finds its way finally to the wastewater treatment plant. But this wastewater from the cruise ships has a rather high sulfur concentration. So during its way to the wastewater treatment plant, it creates the odor problems in the city. So we try to resolve these problems at the port of Kiel. We constructed a wastewater and exhaust air treatment plant at the seaport in order to eliminate the odor problems and also improve the working and operational safety. So the general idea is that the wastewater from the cruise ships with a high concentration of sulfur is discharged into the reaction tanks underground. And above the ground, we constructed a container with the facilities to generate ozone for the reduction of sulfide and activated carbon absorber to eliminate the hydrogen sulfide and odor problems. We also dose the chemicals into the reaction tanks to regulate the pH value so that the wastewater coming out from this reaction tank will be discharged into the city of Kiel, into the sewer system of the city of Kiel without causing any odor problems. So here is the container that we constructed above the ground, and you can see the pipes coming out from the container supplying the ozone into the reaction tank. And this is how it looks like inside of the container, where here are the ozone generators and we have the pipes supplying the ozone. Here's also a short video explaining how the whole system works. So here comes the cruise fart, here comes the cruise ships, and also comes with the wastewater collected during the journey. Here we constructed a reaction tank underground, and above the ground, here is the container that we have seen before. The wastewater from the cruise ships is discharged into this reaction tank and fill it up. So this wastewater from the cruise ships are with rather high pH value, rather high sulfur concentration and rather low pH value. So it caused odor problems. And in the containers, we have the ozone generations supplying the ozone into the reaction tanks. And the ozone will then react or oxidate with the sulfur in the wastewater. And at the same time, we'll also strip out the hydrogen sulfide. So during this process, around 80% of the sulfur will be oxidated by the ozone. And the rest, around 20% of the hydrogen sulfide, will then be sucked into the reaction tank, filled up with the activated carbon, and they will be absorbed. So now, so far, we have already reduced a lot of the sulfur load in the wastewater. And then we also dose the chemicals into the reaction tanks so that, yeah, we regulate the pH value, and in the end, we got the purified air, which will cause no odor problems at the port of Kiel. And finally, we got the green light, and everyone is happy. So the pre-treated wastewater from the cruise ships can now be discharged into the sewer system of the city of Kiel without causing any problems during the way to the wastewater treatment plant. Yeah, so personally, I found this project really interesting. And yes, that's what we want to share from our side. of the exhaust air treatment technologies that we find effective and we are applying in Germany. So what we would like to know from your side is like which kind of these exhaust air treatment technologies that has been proven effective or that has been applied in your countries. We would like to learn that. Yeah, so wait, I stop this. Yeah. So anyone would like to share a little thoughts?
Now we have the biggest audience we ever had in this round. Every time we have 5 more people coming, and nobody is maybe everybody's afraid to say something. Basically, no.
Yeah. Hi, I'm Shrikant again. Yeah. So I would like to share my experience in this odor and exhausted air. So we have a pump work. No, this pump work needs to discharge around 350 cubic meter water per day. We have slope of -12%, and it is compressed rollite system. So that means we need to discharge the water around 2-3 kilometers of -12% slope. No? So that's why we due to the more due to often salt side, due to the how do we say in English, often salt side?
Resistance time.
Yeah, resistance time is increased in the night time. So due to the sediments, and we have this odor problem, and we try to reduce this odor problem by dosing chemicals like iron 2 chloride or calcium nitrate. So when we dose iron 2 chloride, we are able to reduce the odor a little bit only. But when we dose calcium nitrate with the 0.22 liter per cubic meter, then we have a very good results. But the problem is the cost is very high.
Of course, yeah.
Yeah. So the H2S and wastewater odor is reduced, but the cost is very high. So this very little bit amount of water, like it is around as I said, 350 cubic meter per day. It's around about 125,000 cubic meter per year. So for this only small amount of water, I don't want to waste, or we don't want to waste such like big money of 20,000 euros per year or 30,000 euros per year. So if anybody has any knowledge in this field, could you please share with me to reduce the costs? We also look with this ozone air system, but it is initial cost is very high, and it is not applicable for this big length of road lighting. So it's around 3 kilometers, as I said. So if anybody has any idea on this, could you please share with me?
Is it possible to discharge somewhere else?
No, it is not possible. It is not possible. I think we already discussed on this thing. It is from Meiringen. No, no, there is no possible way. Previously the villagers had their own wastewater treatment plant, but it was very costly. So that's why they decided to discharge their wastewater to nearby wastewater
Well,
treatment
did you try to increase the pressure pump? I mean, from the pumping station. Like if you should has at some point you have to let it out the pressure pump. So from the pump station, did you guys think of extending the pressure pump? You said something like 3 kilometers. Like why not 4 or 5 kilometers, something more, so that you will have a less concentration?
Then it will it might I cannot, because this is the fixed line station. If I need to buy construct a new canal system, it will cost much more.
Yeah.
Yeah, it's around 300,000 euros. So at this point, I want any ideas, maybe dosage of any other chemicals or concentration with the variant concentration also I tried, but it was not so much successful.
Yeah, iron is always a solution, maybe if you have the right amount, but it also costs money. How is the diameter of the pipe, of the pressure pipe?
150 DN.
Yeah, maybe there's a possibility to insert air treatment. We use that in some pressure pipes above 200 millimeters.
Yeah, ballistic system.
That you can install and that aerates the pressure pipe. That has a lower cost per year of around by 10, something like that. But then you have something in your pressure pipe. Maybe that is for operations not so good.
Yeah, also I tried with this system, but in theoretically I looked at, but the pressure system, what you said, it's the energy cost of it's increase also the same. Like,
no, I don't mean flushing the pipe. I mean aerating with
oxygen.
A special hose that you install into your pipe. Maybe I find a picture at the moment. Just real quick.
You can check in Uni Techniques. I mean, in the website there is so many kinds of measurements, like one which Klaus said explained earlier. Like you can add air, or you can also find a different kind of dosing stations, like not in one position, like maybe in different stations with isochlorate. Then you can get a high probability of reducing the sulfur in the water. So, and then there is also like a multiple measurements, like you can also use the compressed air to flush it. And then, I mean, it also depends upon the cost variation, how much cost you are willing to give. So I would recommend to check in the website once, and then consult us sometime later. I mean,
maybe I can show you a little bit. Maybe that could be a solution for you.
Okay.
That is a hose that is here on this thing, and yet you pull into your pressure pipe, and then you have a small compressor, very small, and you have a constant dosation of normal air into your pressure pipe, but over a long span of the pressure pipe. And then you have like in a treatment plant, right? The problem is in a treatment plant you have an oxygen sensor, and if this oxygen sensor says oxygen is 0, then you start again with your aeration. And in the pressure pipe that is not possible. And with this hose, that would be a alternative, right? That will be pulled here with a I don't know, with some kind of right, there's a picture here that you put into your pipe, and then it gets sucked through the pipe, and then you have air in your pipe, and then the water stays fresh in a wastewater kind of meaning, for example. It's the same that Siqi showed with it's the same that Siqi showed with the reactor, where we put in air to get the water fresh again. And
thank you.
Could be a solution for you if you want to have more. Then maybe we can discuss a little bit more about this. It's not a solution for Uni Techniques, but I like it. I like it for bigger pipes. That could be a good solution.
Yeah, I will look forward.
So I have very like across a length of 3 kilometers, like how many of these things you have to install then?
One more time, I didn't understand your question.
Like just I had a query that across the length of 3 kilometers, like you said, the piping goes up to 3 kilometers.
Yes, and it didn't have any openness.
I had a query for it. Yeah. So how many of these systems, like the solution that was presented, how many of these things will we have to install in the pipes?
You mean for me, or?
I think what he means is
yes,
how,
yes.
at how many like openings in the from the manholes, like how many entries you should give to
You know, how many
the thing.
openings will have to make?
Basically, I know about 10 installations of what I just showed you. Most of the time, the operators don't want to install such a pipe into their pressure pipes because they are afraid it might block. And normally it will be installed in the upstream of the pressure pipes. If you have like this, you will always install it in the yeah, going, what is it called in English? Sorry, in the
In upstream,
in
in
the
upstreams.
rising parts of the pressure pipe. You will install it because the air goes up the pipe then, and that is very good for absorbing the oxygen into the wastewater. So that's basically what you need would be like a cut through the line, a plan of the line, how it is going through these 3 kilometers, you know, and then you can discuss, okay, maybe we need 100 meter or 200 meter of this pipe there to install. And this is a little bit a project, but could be if you have like 20 years, then it could be very, very good for you for saving cost in all
In the
this
long
calcium
term.
nitrate. I mean, we had like a increase in pricing for this calcium nitrates this year for like double or something. That's because a lot of gas is used for producing this, and that's why this component is so expensive now. And as we have this gas crisis in Europe, then
Yeah.
you have a lot of problems with that.
Yeah, and also we have like due to this war, we had the price of calcium nitrate is also increased due to the materials are coming from Ukraine. So
yeah,
so it is much more costly now. But I will look forward to learn more about this pressuring system. Then I will contact you.
Yeah, maybe you send an email to me or to Siqi afterwards, and then we can make a small meeting. If it's interesting for everybody of you, then we can maybe, Siqi, you make another wastewater talk in the future about this issue.
Yeah.
We can prepare a little bit to show 1 or 2 projects about this because actually I like the system, but in Germany most of the people say, oh, we have so much money in wastewater fees. We put in calcium nitrates everywhere, but now everybody is thinking, oh, it's so expensive, and more of the
They're looking
same
for alternatives.
discussion we heard from you, Shrikant.
Yeah.
And that everybody is thinking about maybe changing a little bit about these chemicals at the moment.
Yeah, if you dose iron chloride 2 or iron chloride 3, but then it is increasing the load of iron in the wastewater treatment plant. So we don't want that also.
Yeah. You have to, in Germany, we say you have to die one death. I don't know what it's called in English, but you know, somehow you have to die. Or you can choose one bad thing. You can have to choose somehow.
Like you have to choose your death. That's
yeah.
in English.
I don't know how the saying is in English. Yeah.
Okay. Yeah. If anybody has any thing, please.
Another possibility would be to in America, it's like everything is closed. They don't have any openings in their sewer systems in the US at some points. And then they put everything in plastic, and they have very, very high concentrations of hydrogen sulfur, but there's no corrosion, and they close everything off. So that is also a solution that could be working for you. There you have no cost at all afterwards, but you have to rehabilitate everything in plastic and cut off all the exhaust areas. And then maybe you can, we also installed this already to have an exhaust filter at one manhole, for example, and suck all the air to this exhaust filter. And then you don't have the spreading of all the odors over the whole sewer system. That could also be maybe a solution, but only if you don't have like 500 openings like a Swiss cheese, you know. That could also be possible. That's what Siqi showed in this air treatment, where we suck the air to one specific point. There we have a treatment of the air, and no other opening in the sewer can have an odor coming out of it, because there's always a low pressure on the sewer, and you have one point where you suck all the air to. But this is also something that you have to look into a little bit more. Yeah, how high is the sulfur load and so on? How high is the concentration? Yeah.
Yeah, currently we have a HTS of maximum peak 20 ppm.
Yeah.
Yeah, that's very high.
Yeah, and it's a peak value only. But in normal daytime we have around 2 ppm, so it is okay. It's fine. We can live with it. But in the night time, due to this retention time, the weekends I'm having minimum of 10 ppm at least once or twice a day.
I mean, it's very interesting discussion. I have to make a little bit of advertisement for next time from the wastewater talk, because actually today we prepared a little bit of air treatment. And next time Siqi also, I know, is prepared
It's about sulfide, yes.
for
Sulfide.
basic
Sulfide
knowledge
removal.
about odors completely. And maybe that would be interesting for everybody here interested in this, where we will introduce a little bit a software where you can calculate this, and then maybe Siqi, you can go into more detail about the solutions that's possible. Maybe also Shrinkran, you want to give us your data, and we will take your project as an example for everybody if you want.
No way.
Maybe.
I think you have forgotten. Maybe I already discussed about these things. I am from Archet for Staufner book.
Ah, okay.
We already discussed this thing, and you have suggested me calcium nitrate of 0.22 liters per.
I'm sorry. Now I remember.
We already discussed on these things. Yeah, that's it from my side.
Yeah. Okay.
Thank you, Srikanth, for your question.
Yeah.
But for everybody else,
So I had a
next time we have more basic knowledge about odors overall, and then we go more into detail about this. What I want to know from all of you guys is, in Germany we have all this air treatment from treatment plants and also from sewers a lot in urban areas. If there's more like agricultural areas, there's not so important a little bit. And how is it in your countries? Is it also that if people complain that there's something to be done, or is it normal that there's odors from sewers and that is okay? Or how do you go about with these issues in your areas?
Mr. Tripathi, I think you have a question.
Yes, so I had one query, like regarding this odor removal in, let's say, an open area, let's say in MSW projects, like municipal solid waste management projects, where you will have the main landfills outside of the city. But to transfer that municipal solid waste, you will have small transfer station all throughout the cities. So usually what I have seen is those transfer stations sometimes get overwhelmed with the load, let's say, and in rainy season you will have all these municipal solid waste outside, and in rainy season you will have a lot this leachate that is produced. What I've seen that usually like some water stream, they usually discharge into it. So what could be a solution? And generally it generates a lot of odor in the surrounding areas. And obviously it's not good that we discharge those kind of leachate, MSW leachates directly into the streams. So what could be a solution here, sir? Like in open area, let's say you have the waste in open. not landfills, let's say in transfer station, like specific transfer stations will be there all throughout the city, right? To transfer the waste to a bigger processing plant.
So you have transfer stations, and then from these transfer stations, they collect into a bigger landfill. I mean, for a big city. That's what you mean, right?
Yeah.
Okay, so
what happens is in small transfer stations, rainy season, it will get overwhelmed, and you will have a lot of waste that will be lying on the tipping floor. And with rain, usually we collect like there will be a lot of leaches that will be produced and a lot of odor. So how do you go about that?
If I may contribute, Shubham Tripathi.
If I may. Yes, please.
Yes, ma'am.
Generally, the transfer stations, whether local or the final station, if they are open, they are not supposed to be with a floor which can tip down. So these landfills are to be constructed with a special base, usually impermeable, say concrete, and so you make sure that the leachate is from these open stations where rainwater can cause nuisance. It is collected somewhere there locally below, and then a local leachate treatment system is planned. This is how it needs to be designed if it is an open landfill collecting station, and making sure that it's not there. So it cannot be possible, or it is not legal that waste management or the dry waste is collected on a agricultural land, for say, or soil below. No, that's not possible.
Yes, it's
I have seen
mostly
many
in
areas like this practice.
Sorry.
Does that answer your question, Shubham?
Mr. Tripathi?
Yes, sir. Like, yeah, I got it. Yeah.
Okay, so Stacy, I mean, you told you're from Kenya, so can you explain, like, in Kenya, is there any air purification or anything, any kind of new technology which you want to share the group? Stacy, can you hear us? Okay, I think she's.
We lost her.
Yeah, I think we lost her. Bad connection everywhere. So, is there anybody, I mean, other than Germany, like, who is having a similar problem or having a similar technology which you want to share?
Yeah, or you know, some other technologies which
Yes,
are
yeah.
proven to be effective.
You guys have any question regarding the presentation? I mean, you want to know anything about this technology, like which we had in the air water treatment, I mean, air purification regarding the sulfur and hydrogen sulfide?
I mean, I heard this is a special thing about the Baltic Sea, where these cruise ships are driving around, and in the North Sea and in the west part of Germany, there's no obligation yet to bring the wastewater into the harbor. There you only drive through the sea, and then there's an opening and let it all out. And that is common practice in all other seas we know at the moment. So basically, it's maybe something for the future, where would it be nice to know. From my perspective, what was interesting to know if there's maybe some other regulations you are following, or what is your motivation to maybe act on odors with treatments. So, for example, does anybody know about treatment plants for air on on wastewater treatment plants in your areas? Is that common, or is that happening somewhere?
No, it's not common in my country.
But how do you guys treat the air or the pollutants or some kind of harmful air in the country? I mean, there should be some kind of way.
With
I
the
mean,
absorption columns, but
okay.
when it's very toxic, then we treat them. Otherwise, low toxicity elements can be just
Ignored.
thrown
Okay.
away in the air.
So absorption
I'm
columns.
sorry.
Okay, is it with activated carbon or?
Yeah, with activated carbon filters.
Okay.
Isan, you want to say something?
Yeah, I just wanted to add some comments about this. In Iran, for some area that is close to communities because of some problems, or sometimes in buildings that have water recycling, they have some kind of treatment for odor. I mean, they have some vacuum pumps that collect this air from above these reactors. It's not important what's the way of treatment of sewage. Maybe it's just RBC, or maybe just other kind of process for treatment. But for air treatment, they collect the air and they use some kind of activated carbon and some kind of natural stones that can absorb this kind of odor. But it's expensive. I mean, it's not really common. But in some cases, I visit some small sewage treatment plants that do that.
So is it successful? I mean, is it? I know it's costly, but is there any other things so that you can minimize the cost, or maybe build some small plants or something so that you can minimize the cost and share the cost?
They do some kind of, for example, I cannot mention exactly in English because of coronavirus. I do not have so much time to practice English more and more, and but there is some kind of natural process. I mean, for example, some part of trees, a special kind of trees, that they make a column of the stem of this vegetarian, I mean, and they can absorb when they mix with some kind of liquids, they can absorb, and there is some tower, for example, 3 meters, 4 meters high, and they fill this tower with some kind of mix of this natural material, and they send the vacuum air to this tower and do that. And I see some result of the input of output of this column, and it's some extent accepted. I mean,
can you share any kind of some link or maybe some article about this technology to the group? I mean, if anyone is interested, they can just go through it if possible. Thank you.
Yeah, for sure. I try to my best to collect and share it with the group. Okay.
Thank you so much.
Thank you.
You're welcome.
Okay. Does anyone have further questions to this topic or to our presentation, or?
I mean, it was a very nice discussion, I think. We are already at 11, Siqi.
Yeah.
Maybe you want to inform a little bit about next time?
Yeah. The next wastewater talk will be on 5th May. Sorry, 5th May, and we will talk about the sulfide balance in drainage systems, focusing on the software for the simulation of hydrogen sulfide formation and emission in our sewer systems. So it's a tool to help diagnose the older problems in our sewer system and to find the solutions for it.
Yes, and also we will after the meeting today, we will make a little bit about what solutions could be possible. Also, so if you want to further explore this issue, be happy to join us on 5th of May, and maybe tell colleagues who are interested. We are very happy that we again had a record attendance, and we are wanting to explore this in the long haul. So if you are interested or you have other issues for the future or something that we should talk about, then we would be happy to get this from you. And and if you want to maybe explore all the last wastewater talks, if that was interesting today, all the presentations and videos of the last wastewater talks you can find on where? Siqi, where can we find this?
For the videos, you can find it on YouTube, and for all the information like videos, presentations, and the plan for the next month, you can find it on the Wastewater Talk website. And I will, the link I have put it in this presentation, and later I will make it available and send it to everyone so you can check it out.
If you want to leave your email address in the chat, some of you already did that, then we can send it to you and send you the link, and we are very happy that you joined us. And yeah, if you have not enough, in 15 we make 2 sessions now, one for the Eastern Hemisphere and one for the Western. And
Western
that
Hemisphere.
will be
yeah.
At 3 today, right?
Yes, at 15.
Yeah. So
15 is Central European time. So
basically it's the same content, but maybe different people. If you want to join us there also, feel free. Yeah. Thank you for your attendance. Thank you, Siqi,
everyone.
Thank you, everyone.
Yeah.
Then we see us next month.
Thank you, guys.
Thank you. Bye-bye.
Bye.
Bye.